Well, hello guys, here Mr. G with another video. This time we're going to be solving a question on stoichiometric for the grade 11, but it is applicable for the grade 10 as well as the grade 12. So get your notebook, get your pen, your pencil, so we can answer this question together. The question says, in an experiment, James mixed 50 cubic centimeter of 0.6 mole per cubic decimeter lead to nitrate solution with an excess of hydrochloric acid. So the lead to nitrate is in solution, okay, and is reacting with hydrochloric acid, and the hydrochloric acid is in excess. So let's mark that part, excess of hydrochloric acid. In other words, the hydrochloric acid in the chemical reaction is in excess. Therefore, the lead to nitrate here will be the limiting reagent. Will be the limiting reagent. They are telling you in the question. A white precipitate form, and I did write here in bracket what is a precipitate. A precipitate is a solid that forms during a chemical reaction. In other words, the precipitate is going to be the product of the solid that could be a product. So this substance here is going to be the precipitate. Okay, that is the precipitate. So now here we have, and they say he determined that the mass of the dry precipitate to be 5.2 grams. So when the reaction happened, he measured the mass of that precipitate and he determined that he get 5.2 grams. So guys, that one is the actual yield. That is what this James actually get in this chemical reaction. So here, this is the actual yield. That is the 5.2 grams. Okay, now question A, what is the name of the precipitate that formed? Very simple, we're looking for the name of this one, and we have lead to chloride. Lead to chloride, that is the name, and it's quite simple. Now, what is the theoretical yield of the precipitate? Now, to calculate the theoretical yield, we need to know which one is the limiting reagent, which in this case is given to us. So the first thing we have to do, this one is question B. The first thing we have to do is to calculate the number of mole of the limiting reagent we have here. Okay, now for that, lead to nitrate, all right, for PbNO3 bracket 2. This one is the one we're going to work with because it is the limiting reagent. Okay, so what we know about that solution, we know that the amount of the solution used was 50 cubic centimeters. Remember, we cannot work in cubic centimeter, we have to convert, and I think this is the right moment to convert. You divide by 1,000, let's write it here, it's 50 divided by 1,000, that will give you 0.05 cubic decimeters. Okay, now what else do we know? We know the concentration of that solution, which is going to be 0.6 mole per cubic decimeters. Guys, there we go. And then we are going to calculate the number of mole. Okay, so how do we calculate the number of mole? What formula can we use here? Number of mole is equal to let's write the formula as it is given to us. Concentration is equal to number of mole divided by volume. All we have to do is to substitute what we know here. The concentration is 0.6, the number of mole is what we are looking for, and the volume is 0.05. Be careful when you substitute, don't you substitute without converting. So if you rearrange this one, you get that the number of mole is going to be equal to 0.03 mole. Okay, now what we are going to do next, we are going to work with the ratio. We are going to work with the ratio. Okay? Ratio of what? We are going to work with the ratio of the limiting reagent. We're going to write LR to the product. Okay, so in this case is PB NO32 ratio to PB Cl2. This is the ratio we are looking for. And remember, the ratios are the numbers at the front. So if we go back to the chemical reaction, here we have, that is the ratio we're going to use, or the substances we're going to look for. You can see that the numbers at the front is 1 and 1. Therefore, the ratio is 1:1. It means that if you have 0.03 mole of lead 2 nitrate, you will get also a number of mole here equal to 0.03 mole. Okay, that is what does it mean. So now we have the number of mole of the product. So using that number of mole, we are going to calculate the mass of the precipitate, which is in actual fact the theoretical yield. So all we have to do is say number of mole is equal to mass divided by molar mass. This one is for lead 2 chloride. Okay, so here we need to calculate the molar mass, which is quite simple, but I'm going to do it just in case somebody don't remember. So we're going to substitute in the same reaction. This one is 0.03 equal to mass divided by molar mass. Now molar mass, the molar mass of PB is going to be 207 plus 2 times the mass of chlorine, which is 35.5. So it's plus 2 times 35.5. That is the molar mass, of the way of calculating the molar mass of lead 2 nitrate. Guys, this is just simple maths, but when you substitute, you get that the mass is going to be equal to 8.34. Let me see, yes, 34 grams. That is the answer for question B. This is the theoretical yield of this reaction. So theoretical yield means in theory how much that could be getting. It doesn't mean it's going to get that amount. In actual fact, if you go to the question, James did not get that amount, it got only 5.2. So calculate the percentage yield, guys, is quite simple. And this one is C, percentage yield. You need to remember that percentage yield, let's fix that word, is equal to actual yield divided by theoretical yield multiplied by 100. This is the way of solving this one. The actual yield was given to you and it is once more 5.2. So when you substitute, this is 5.2. The theoretical yield is what we calculate. Okay, 8.34 multiplied by 100. When you solve that one, will give you that the percentage yield was 62.35%. That is the answer for D. This is the end of the question as well as the end of the video. I hope it helps. It's a good question to practice if somebody struggle. In this question, they giving you the reaction that is in excess, or the reactant that is in excess, and the reactant that is the limiting reagent. Next time, guys, don't miss the video. We're going to be solving another question in which we have to actually determine which one is the limiting reagent. So this is the end of the video. Thank you for watching, guys. Thumb up. I'll see you next time. Subscribe for the channel. Mr. G here.